Hey, and welcome back. This video is going to be about charging, battery charging. I'm going to work through the Sport Cub manual, and the first thing we do on page 4 is battery charging. So you can read that, and but basically what it says is since I've described two different battery charging methods, I'm going to demonstrate both of them in this video. So the first one I'm going to demonstrate is the Thunder Power charger, and we're going to charge one of the 1800 milliamp batteries that just came out of the package. And the other thing I'm going to do is take the Bind and Fly charger that came with the Bind and Fly version, and I'll charge the 1300 milliamp battery after I start this one. And so let me get the camera set up so you can see what I'm doing over here, and I'll be right back. Okay, welcome back. I'm over here, and you're looking at my old Gen Air grill that used to be in this house. The Gen Air grill got removed, and I saved this. And it's a great little thing to nice metal, heavy metal to charge LiPo batteries on, so we can see what we're doing. And so what I'm going to do is charge the 1800 milliamp hour 3-cell 20C charger, battery, and I'm going to use the Thunder Power charger over there. However, the first thing and most important thing you do before charging anything is to see what the battery voltage is. And this is the voltage checker that you get off of Rise and Hobby. It's a nice little thing, got a little protective cover on it. It's by E-Flight, okay, and it's about $13. But it's most important $13 you can spend if you own LiPo batteries. So what you do is the black wire here, is the ground lead. It always goes to the number 1 pin on the checker, voltage checker. So you plug it in and it'll tell you what's going on. So it says all cells equals 11.4, cell 1, cell 2, cell 3 are all about 3.8, and so it's 11.4 in total. Now that's about normal when you buy one off the shelf. That's what you call a maintenance charge or a storage charge. It's about the nominal capacity. As it says, the nominal voltage is 11.1, so it's 11.4. So that's about the what you get when you buy one brand new. So so how do I charge this? This is an 1800 milliamp hour battery, and so I would only charge this at a it even says on the battery up to 1C charge rate. Okay, so 1C is 1800 milliamps or 1.8 amps. Okay, and so I won't charge it anything higher than that. And for an 1800 milliamp battery, I'll use the Thunder Power's ability here to set the capacity. Okay, so let me zoom in on this. And so first off, you have to make sure it's on the LiPo charge, and then you have to press this once, and you have to make sure that that's on a 3S pack, because this is a 3-cell battery. It says so right on it. 3S in the front. Okay. And then you have to hit the enter button here to switch over to the amp capacity that you want to charge it at, and up to a 1C charge rate, meaning 1.8. The 1.5 is probably a reasonable approximation of that. I wouldn't go over 1.8, but certainly the 1.5 is less than the 1.8 capacity of the battery. So I'm going to leave it at the 1.5. I'm going to zoom back out, and next I'm going to show you this board that comes on it. The 3 connectors down here are for Thunder Power. It even says on it TP packs. So 2, 3, 4, 5 or 6 pack of Thunder Power has a different pin placement than the ones you get from E-flite. So the E-flite ones go up here, the Thunder Power ones go up there. I use both E-flite and Thunder Power batteries. So these can only go in one way. The battery has a little arrow indentation right there, so that's the only way you can plug it in. And so because this is a 3-cell pack, it goes right there. Okay, that's for 2-cell, 3-cell, 4-cell, and so forth. Okay, then the other side right here gets plugged in. And so how this charger works is there we go. So how this charger works, it charges through the main wire here, and the voltage and balance, remember this is a balancing charger, so it balances the 3 cells, and so the sensing and the balancing is done through this board, but the charging is done through the main wire. And so what we'll do is, let me zoom back into this, and I'll show you what happens when you hit go. So when you're ready to start charging, the battery is plugged in to the board and plugged into the power cord, which comes from the side over here. So when you're ready, you press and hold this until you hear the beep. And it says LiPo charge 1.48, so it's recognized that the cell is connected to the board, and then it does an initial charge for a few seconds to make sure everything's good and balanced, and then you'll watch this amperage go up here to the 1.5 setting. So it's at 1.25 and now up to 1.5, and it'll stay at the 1.5 range, and so you can read the instantaneous voltage of the battery. At this point, this is the charge rate that's going on. That's the number of milliamp hours that have been added to the battery, and that's the time in minutes and seconds. So this battery will probably take about anywhere from 30 to 45 minutes to charge, and so from time to time I'll come back and show you what happens as this charge goes through. So you'll slowly see this current voltage of the battery go from the 11.4 that I think we started with. So that will slowly increase, until it gets to 12.6. 12.6 is the maximum voltage that this battery should be at. Okay, so once it gets to 12.6, you'll see that the amperage, the 1.5 amperage, will continuously drop over 15 or 20 minutes, whatever the rest of the charge takes, so that the voltage is held at 12. The voltage of the battery is held at 12.6. This amperage drops, but continues to add milliamp hours over a little bit shorter period of time. So as that occurs, I'll turn the camera on every once in a while, and you can tell by the time we got going here that how far of we've gone. So we've been charging for about 2 minutes here. I'm going to stop here, and I'll probably wait until this gets close to 12, and then you'll see this hold at 12.6, and then that start dropping. So I'll be back in a little bit. Okay, so you can see after about 19 minutes there that the voltage in the battery is up above 12, and that so that the voltage is at 12, the charge rate is still at 1.5. We put in 491 milliamp hours after 19 minutes and 53 seconds. So we'll just keep monitoring here, and next time you'll see this is probably going to be close to 12.6. Okay, you can see we're up to 12.52 volts, and we're still at 1.5 charging amps. I'll pull back for a minute to explain one other thing about batteries. This battery here, note what it says right there. It says up to 1C charge rate. Please read all safety precautions, but up to 1C charge rate. Okay, I want to explain for a minute what 1C means. So basically 1C, C is the capacity of the battery. This battery has an 1800 milliamp hour capacity. So the charge rate of 1C is 1.8 amps. You can charge faster than that, and it will probably work. However, you're taking the risk of it not being able to, you might ruin the life of the battery. So I only charge at less than 1C. And I've got batteries that are 8 years old, still working just fine. If you abuse a battery, it will reduce its life. It can even puff up, and you'll lose it completely. If you have a puff battery, by the way, let me show you. This battery is nice and square. Okay. And later on I'll show you a puffed battery that I'm going to throw away. So let's see how our charge is doing here. Okay, coming up on 1.6. I'm sorry, 12.6. So now you see the amperage drop down to 1.48. And so the 12.6 will stay at 12.6. Watch the milliamp hours down here continue to go up, and after 34 minutes and the 1.48 amperage right here is now 1.47. So this is going to stay at 12.6. That's going to continue to drop down until it's probably around 0.2 amps, in that range. And so this will continue to go up, and will likely get up to I don't know, we'll see, 1300 milliamps. So this thing is not by any means finished charging, but it did reach the 12.6 volts. And that's the power of a real nice charger. Is it's going to continually reduce the amperage, holding this at 12.6 and continually adding juice into the battery. So I'm going to turn this off, and we'll be back in a minute when the amperage gets a little lower. Okay, back again, still at 12.6 volts, down to 0.55 or 6 or so charge rate. I'm going to show you another battery here. This battery is slightly puffed. In other words, if I squeeze it like this, I can feel it being a little puffy. So this is slightly puffy. Okay, but that's not why I'm throwing it away. Why I'm throwing it away is because one of these balance leads broke out. You know, this battery is probably at least 8. Let me see. Yeah, it's probably 8 or 9 years old, and so it's not surprising that after a long use, some of these things break out. But it served me well. Got a lot of use out of it, and only slightly puffy. I couldn't find a really puffed battery because I don't abuse them both either charging or in an airplane. The worst thing you can do with a battery that'll make it puff is to run it down to its lowest possible charge rate, which is like 10. If you get a battery down below 10, 9.9 or below, you might puff a battery. The other way to puff a battery is to charge it too fast. If you charge this at 3 amps or 4 amps, it might puff the battery too. So we'll keep monitoring what goes on here. We're 930 milliamp hours in, and I'll be back when it gets down to maybe a charge rate of 0.25. Okay, I'm back here. The charge rate is down to 0.23, 0.22 now. 42 minutes and 40 seconds. The milliamp hours will likely get over 1,000, but we'll see. Now 1,000 is more than 50% of the 1,800 milliamp capacity, and because this was a brand new battery on what you call a maintenance or storage charge, which is about half the capacity, or which is about half of the about half the capacity, or about at the nominal voltage of 11.1. We'll see what happens here. I'm going to be quiet, and I may edit out a bunch of footage here, but we'll see what happens. Okay, there's the sound. It's finished. 954. I'll let it quit beeping. Alright, so 954 milliamp hours put in after 44 minutes and 57 seconds, and it'll be quiet in a minute. The amperage is down to 0. The voltage is still at 12.6. And to stop the process here, I'll go ahead and do it. So 954 milliamp hours after 44 minutes and 57 seconds, 12.6 voltage. I'm going to press this once. Okay, and that just goes back to the main menu. Let me zoom back out here. Okay, and so I'm going to unplug the charge lead. Okay, and then I'm going to unplug the balance lead, and then I'm going to power off the charger just by unplugging it there. And a bit of information about how you plug these things in. I'm going to take this out just as a sample, so this isn't going anywhere. However, no, that would be dangerous. Never plug this into that when you got a battery here, because that shorts out. So I'm not going to do that. Never mind. Ignore that. Okay, I'm back, and I want to show you a bit more about how you plug and unplug batteries. This is an extension. I actually made it. So I got a female end, I got both a male end and a female end, and so this is safe to plug into a battery. I'm going to take that's the female end. By the way, batteries must always have a female ending. Alright, I can't stress it enough. If you make your own batteries and make your own endings, this has got to be female. I'm going to take the male end and plug it into the female end, and note that it's directional because this is a flat side, that's a flat side, that's the plus, the flat side is the plus side, and so you can only plug it in one way. To plug it in, you sort of hold on to the end of it and you push it in and it goes in very nicely. To get it back out, you grab and you just twist your fingers together a little bit like that to pull it in. So push it in, it's in all the way. To pull it out, you get your fingers, 2 index fingers together, and you just pull it out. So that's how you plug and unplug. Never do what I was about to do before, which is plug something like this in where those two could contact. Guarantee you're going to get a puff battery and it's going to even explode on you. So never do that. Okay, I'm back and I'm going to explain one other thing about a battery. A lot of times I'll use Thunder Power batteries. They're very good batteries. Been using them for a long time. This is a Thunder Power 2100 milliamp hour 3-cell batteries, because you can count the 3 cells there. This is Velcro, and I'll explain about putting Velcro on batteries later. But when I make this battery comes with bare leads. In other words, it has the wires here but no connector. And when I buy batteries like that, my preference is to put a Dean's plug on. So this is a Dean's plug, and you can see it's different than the EC3 plug. Okay, so a lot of times I'll use Dean's, and because the connector in the airplane is EC3, if I want to use a Dean's plug, I make one by taking an EC3 and adding a Dean's male connector on it. Remember, this is always female. This male connector obviously looks like a male connector. And so when you plug them in, so this is an extension. So this is male going into female, and on this end is back to female again. So it's safe to plug in as an extension. Some people like the Dean's way it plugs in and out. I do. But I also like the EC3s. I've gotten used to them. So if I want to use one of my Thunder Power batteries, I have an extension that converts Dean's to EC3. You don't have to make it yourself. You can buy them. Horizon Hobby sells a EC3 to Dean's connector in both, probably both directions. So you don't actually have to make them yourself, but so you can buy these. Thank you.